Welcome to our short, brief video to help you with your child when they're doing some form of subtraction. Hopefully you've watched the earlier edition of subtraction, and today we're going to have a look at what happens when children need to exchange when the subtractions become more complex. In front of you, you can see what we call a tens and ones place value grid. And on this particular grid, when we're first looking at early subtraction, if we were giving our children a calculation such as 26, 26 subtract 12, the first thing we do is we get our children to create the actual calculation. And you can see that I've made my 26 with 2 tens and 6 ones. Notice how I've laid out my 6 ones, and that relates to our earlier layout of related to the tens frames. It's really important that children lay out the 6 like this, because then when we start to subtract, it'll help them quickly calculate what's left. So if I were taking away 12 from 26, I'd start off by encouraging the children to think about the value of the 12. There are 2 ones in 12, so I would ask them to take away the 2 ones, and then in the 12 the 1 10, and what's left would be your calculation. So first of all, we would start off with the concrete resources. For a calculation like 26 take away 12, we wouldn't encourage children to do a formal written method, because that's the sort of calculation we'd like them to develop working out in their head. When the sums become more complex, say for example we've got a calculation, we're going to go with 36 again, and we're going to subtract 19. So our calculation would be 36 subtract 19. Here's when things start to get more interesting. You'll see first of all that I've built the calculation in the same way. And now is the point where, as long as building it, I'm also going to write the formal calculation so the children can see what's happening. When laying out the formal calculation, we need to be really mindful of where our tens and ones are. 39 subtract 16. If your child does lay out a calculation and doesn't line up the tens and ones, maybe just let them see how that plays out when they try to exchange, because actually making that error is a really important process. Now, when we're doing this calculation, the language that we use is really important. And I would start off by saying, I've got 6 ones and I want to take 9 away from it. So 39, sorry, I've done it the wrong way around. 36 subtract 9, that's not going to work at all, is it? 36 subtract 19. 36 subtract 19. And let's make sure that says 19. So, as I just said, I want to subtract 9 ones from 6 ones. Is it possible to do that? And because I've laid it out like that, the children can see that actually there's no way I can subtract 9 ones from that calculation. So what do we need to do? And here's where that magic word comes in. And that magic word that we talk about in subtraction is exchange. It's not borrow, it's exchange. I need to exchange 1 10 for 10 ones. I'm exchanging this 1 10, and in its place, I'm going to put 10 ones. 1, 2, 3, 4, 5, my 10 ones. Now, to show that in my formal calculation, I exchange my 1 10 and I make that into 2 10s now, and now I make that into 16. So I can see that I've still got my 6 ones, and I've also got my 10 ones that I've exchanged for it. So now I'm able to figure out what 16 subtract 9 is, because I've got my 10 ones here. As I've laid out my numbers in this way, my 16 ones, if I'm taking away 9 ones, this is fairly simplistic in that I wouldn't expect children to start counting 1, 2, 3, 4 and taking away. I'd expect them to recognise that this is 10. So if I'm taking away 9, there's going to be 1 left. And that's my 9 that I'm subtracting. So 16 subtract 9. Now here's 7. And again, we want to encourage our children to not count those numbers, but to recognise that it's 5 and 2 more, so that it's 7. 16 take away 9 is 7. I've got 2 10s in this case. I'm taking 1 10 away, which leaves me with 1 10. 36 take away 19 equals 17. Don't be surprised if this takes an awful lot of practice using physical resources to help your child. This isn't the sort of calculation that's going to stick straight away. We'll do another example and I'll show you how you can just draw it if you haven't got resources at home. So the example that we're going to do now is going to be 42 subtract 28. 42 subtract 28. So the first thing I'm going to do is I'm going to draw my 4 tens. So 42 subtract 28. So you can see here I've got 4 tens and 2 ones. Notice again how I've laid them out. I've almost mimicked my my deans here that are my 10, and I've started to lay out my ones as a 1. So I've got 2 ones and I need to subtract 8 ones. And you'll see that because I said I've got 2 ones, I need to subtract 8 ones, it's really clear that that's not possible. So I'm going to exchange. I'm going to exchange one of my 10s for 10 ones. And I'm going to set my 10 ones slightly apart. And notice how I've drawn them like a tens frame. So just as I've done in my calculation, I'm going to exchange my 4 tens for 3 tens. And now I've got 12 ones. And I can see in my picture that I've got 3 tens and 12 ones. So that there's no mystery as to where this exchange went to. I exchanged 1 10 for 10 ones. And I would really emphasize that children need to be able to say, I'm going to exchange 1 10 for 10 ones. So now I've got my 12 ones and I want to take 8 ones again. Just as when we use the Dean's model, if I'm subtracting 8 ones from here, I'd want children to recognise that there are only 2 ones left when I subtract the 8 ones. So I'd want them to start by crossing or just crossing out with ones to see that there are 2 left from the 10 ones that I've exchanged, and I've got the other 2 there, which gives me the answer of 4 ones. Now, this is where sometimes children forget. I've got 3 tens, I want to subtract 2 tens. That leaves me with 1 10. So both of those methods will help your child's understanding of subtraction. But please, if they're getting bored with that method, if they want to use something different, if they want to practice this method, please do give them those experiences. And the other thing I would say is there are times when children forget halfway through a calculation and start adding. So one of the things that we always talk about is, in a subtraction, would I expect my answer to be larger? So if they have done that accidentally, or they've sort of forgotten halfway through and the answer turns out to be larger, just ask that question. When I'm taking something away, do I expect to end up with a bigger answer? As ever, any more support you might need, please do get in touch.